Okay, let's clean up our electronic whiteboard. And now we are going to talk about full wave rectification. What do we mean? Don't worry, they will understand very well. Now let's talk about full wave rectification. With 4 diodes, we are going to transform alternating current to direct current. Let's see if our graph turns out well. More or less it has come out. It was not so neat. I am going to improve it a little. I like it a little more perfect there. We are going to have an alternating current input, and here we have a direct current output, and look how it does it. It is very easy to understand. You know, what we have here are electrons entering here and coming out here. But in the next moment in time, the electrons enter here and come out here. All the time this is fluctuating because it is alternating current. Now we are located at a moment in time. At this moment in time, suppose that the electrons are entering on this side and leaving on this side. When entering with the electrons, we find these 2 electron check valves. If you pay attention, on this side the electrons will not be able to pass because they are encountering a diode in reverse. Then the electrons will be able to pass through this side. Arriving at this point, the electrons will no longer be able to pass through this diode because it is in reverse again, and they will come out on this side. At the moment that the electrons enter here, they will circulate towards here and they will go here, converting this side as negative. Now, the next moment in time when the electrons come in through this other side, what happens? At this point, we also find ourselves with a diode in reverse and another diode in direct. The electrons will be able to pass through the diode that is in direct. And at this point, exactly the same thing happens again. They meet again with another diode in inversely, and the only way out of the electrons is through this path. Notice that we don't care if we enter here or here. Thanks to this configuration, which is called full wave rectification, thanks to this diode configuration, the electrons will always be entering the circuit through here. What does it mean? That they will go through the entire circuit that they have to feed, and the output will always be on this side. This always makes the other pole positive. So, just as a full wave rectifier works, when you find 4 diodes on a board, how am I going to show you now? We are always producing this effect. We are trying to rectify. Let's see it like this. Look, here we have 4 diodes and here 4 diodes. Here are 2 rectifiers. A detail, you see them all placed in the same position, but the tracks behind the plate, let's say that they are finished accommodating so that they are always in this configuration. We are going to see another different board. Here we have an inverter system board. Look here, it has the 4 diodes. There is a 5th that I will explain later what it is for. There we have the 4 that are 1, 2, 3, 4, which are placed in a different way. They are not in a rhombus, but it does not matter. The tracks end up accommodating so that they are in this configuration. And these are the wave rectifier circuits complete. Full wave rectification with 4 diodes. Generally, when they are circuits for boards, the diode model used is the 1N4007. We are now going to explain one more and fundamental component of all full-wave rectification, which is a capacitor, and with this we are also going to delve into what capacitors are, but I am not referring to the capacitors that we have found up to now in conventional air conditioning, but I mean these capacitors that are mounted on these plates, and that are the largest capacitors that we find in the inverter circuits in the outdoor unit. We are also going to explain how these work and how their state is controlled. Let's stick with that topic.